In early May 2025, I got the opportunity to visit Bondtech in Sweden. They have a new factory and invited me to go take a look, ask some questions and see what they're all about. In the last video, we had a great tour of the factory, taking a look at how they manufacture all of their parts. But in this video, we're doing a Q&A on INDEX, Bondtech's new tool-changing system coming November 2025. This video is technically sponsored by Bondtech because they paid for me to visit their factory, but the creation of the video is just sponsored by me, so be sure to visit vector3d.shop. If you own a 3D printer, you're probably well aware how important calibration is to precise prints. That's why I created the Cauliflower and Cali Lantern, of which I just released the very latest design, Cali Lantern Mark II. It's a step-by-step calibration process that gives you an STL to print, measure, view the results and score, and guides you through all the corrections needed to improve your prints. You can check it out via the link in the description below.
Okay, so the first question is, when will Bondtech bite the bullet and build or sell a printer running INDEX?
That's a loaded question, maybe. But
well, okay, if and when, is that a possibility? Is that a consideration, do you think?
We have talked a lot about making the Bondtech printer, but we kind of don't want to fight with our customers who build printers.
Mm-hmm.
So I don't think we're going to see that happening. But I mean, tell us, what do you think?
On INDEX, what's the situation with flexibles? Are we expecting flexibles as well as rigid filaments?
Yeah, for sure. I mean, that's a big reason why this exists, to combine flexibles and rigid filaments in the same print. So far, we have tested down to 85A. I don't really foresee more flexible filaments, softer filaments being a problem.
Right.
This doesn't use the LGX gears, but it's using large gears. So yeah, it's going to perform quite well with flexibles.
Is there a specific feature of INDEX that allows it to do flexibles particularly well, or what makes it adaptable for both?
Yeah, I mean, we have the dynamic dual drive gears, which kind of adapts on the fly to the different kinds of filaments, and that's what allows the INDEX to swap between different filaments without changing a tension setting. Yeah, so if it does need to dig in harder, it will.
Is there going to be a non-CPAP version? So for anyone that doesn't know what CPAP is, it's having the fan remote to the tool head, so you blow through a tube. Yeah. And then the cooling comes out the nozzle. The cooling channel interface will most likely be modular, so you as the user can choose whatever cooling solution works best for you. I mean, the noise level of CPAP can be an issue for some, but it's going to perform the best in terms of part cooling performance. And I think it looks pretty good as well.
Yeah, for sure.
I think we just need to get a black tube.
Yeah, a black one. Yeah, we really have to. I mean, since it has such high static pressure, we can keep the cooling channels quite small and thereby keeping the tool head itself quite slim, so we can fit more tools, because every tool needs clearance for the tool head between them, right?
Yeah, so as soon as you're widening that tool head, you're reducing the improvements that INDEX makes. Right?
Yeah, I mean, then we're reducing the number of tools we can fit on any given printer. So we want to maximize that number of tools.
I don't know if I fully understand this question, but can it print PETG like a bamboo with a Panda Jet?
I guess the Panda Jet is a part cooling solution.
Yeah.
And I mean, this has good part cooling. We have a lot of headroom. We rarely run over 40% even when we're printing PLA. So
yeah, some CPAPs can be basically so powerful you can almost blow a printer off the bed if you put it to 100%.
Yeah, for sure.
I think it'll be fine.
It can print PETG just fine. Yeah.
How hard is the hardware setup?
I mean, in true Bondtech fashion, we're going to try and make it as simple as possible. We're, of course, going to have full documentation on our supported upgrade kits on how you install it step by step. Every screw will be accounted for. For the printers we aren't supporting, we're going to do some kind of development documentation, what things to consider when you're integrating it, as well as providing reference geometry.
Sure. So your mileage may vary based on exactly what you want to do, but you're going to take care of hopefully the most common situations for Yeah,
for sure.
The most obvious question, I suppose, when can I buy it?
We're aiming for November. We're gonna have to see where we land. As of right now, we are on track, but that might change.
The next one is definitely a joke. Will it blend?
It will. Yeah.
You get a strong enough blender, you can blend it.
Just don't inhale the fumes.
Which parts will be reprintable by the user?
Yeah, I mean, for when we're doing like custom integrations for open source platforms, the integration parts themselves will be open source. Yeah, I mean, nothing is really set yet, but that's what's going to have to be open source at the very least. So you can print them yourself, adapt. Maybe you'll have to adapt them for FDM printing, because we're most likely going to release like our SLS print files as is.
Yeah, so yours will be, your design will be optimized for your manufacturing, your production, your distribution of the SLS that you do in-house.
We may do FDM versions, but yeah, we'll see.
Yeah. Can I have it?
Yeah, you can, if you pay the price, for sure.
What is the max flow rate?
As with all Hotends, that's going to depend on what printing temperature you're using, how much part cooling you're using, what the chamber temperature is, etc. I guess like a round number would be 25 millimeters cube. If you're printing like PLA with large nozzles, you're going to be able to go higher. If you're printing ABS with small nozzles, you're going to have to go lower.
Are we expecting to be able to use this on any firmware, RepRap firmware, Marlin, etc.?
I'm not sure about Marlin. Probably it will work. As for the tool changing scripts, I mean, they're very simple, at least in Clipper, so maybe. RepRap firmware will work for sure.
What about a spool management solution? We can see one here on the desk. I think it's just about in screen. But obviously, the more tools you get, the bigger printer you get, suddenly you could potentially have 10, 15 spools. Yeah. Do you have any plans for a management solution for that?
We're not going to be selling a spool management solution. Instead, we're going to maybe develop one that we release for FDM printing. Maybe we'll recommend a solution that's already out there. We're not sure yet.
Can I get the induction heating unit separately?
Not right now, no. But maybe in the future.
Definitely not before the rest of it's released.
No. I mean, we're gonna be selling the tool head, the full tool head by itself.
So I guess you'll have spares available for people that have bought the whole thing.
Yeah, for sure. Theory, and you may or may not be able to use it standalone.
A current list of printers you intend to support? I think we sort of covered that already.
Aside from the ones you already mentioned, we have one running on the Warren Trident. And the Nozzle SV08 is going to be supported at release, and maybe the Nozzle Zero as well.
Will there be Hotends available for printing at particularly high temperatures or highly abrasive materials?
Highly abrasive will be for sure supported. As for like very high temperatures above 300 degrees, probably not. Maybe we'll release like an industrial version further down the line if there's enough demand for it.
I mean, at the moment with 300 Celsius, you're still covering like pretty much all the filaments that people will be expecting to buy, but not the ridiculous industrial ones where you need basically an oven to print in anyway.
No, I mean, we're going to test like PPSCF and stuff like that and see if it's viable. I mean, we can get the nozzle itself way hotter than safe. But as for like what flow rate can we attain, will the silicone sock survive? And
it's all the rest of the system that has to also be able to cope with.
Without like, we could make a version that works with that for sure. We will make it work with the most common scenarios to begin with.
What is the approximate weight? I mean, maybe relative to a stealth burner or something?
I'm not really sure. We're using a 22 millimeters deep NEMA 14 motor right now. So it's a little bit heavier than the normal 20 millimeters deep one. Right. But at the same time, the heating solution, the tool and the coils and stuff is lighter than a traditional hot end. So
yeah, I mean, a lot of people have been using copper-plated blocks I mean, a large copper block weighs quite a lot,
Yeah.
and as soon as you slim that down to what is essentially a tube.
Yeah, I mean, it's not going to be that like the ultimate tool head when it comes to speed, but it's not going to be too bad. I mean, it's fairly light.
How fast does it heat? So I guess that's from a tool changing perspective as you switch from one to the other.
Yeah.
How quick does it go from nothing to?
That depends on the filament that's in the nozzle, what temperature it needs, and stuff like that. Anywhere from like 4 seconds up to 6 or 7 or 8 seconds. A full tool change being like at the lower end 12 seconds up to maybe 17 seconds.
Okay.
Depending on,
Is that including any purging that would need to be done?
It's from printing to printing.
Okay. So the whole.
Yeah.
This question regards the specific rat rig implementation, I suppose, in comparison to this one, where the kind of implementation is inverted, whereas one's installed at the front and one's installed at the back.
Yeah.
Is there any particular reasoning behind those two differences?
This, and I mean, none of the platforms we are displaying it on is final integrations. We're doing like a full redesign of the tool head as we speak. So it's going to look different than this. As for if it's going to be on the front or on the back, it's not set yet. We're trying different things and seeing how it works. And I mean, it's the development process. So.
Yeah, I guess it depends a lot as well on the machine that it's going on. If you try to put these tool heads at the back of this printer,
that
you have nowhere else to print.
No, that will sacrifice the entire build volume.
Whereas the rat rig obviously has a lot of space at the back, and that allows you to then keep the panel on the front.
But we might do the rat rig on the front. It's not set.
Yeah. So. Okay. Luke's laboratory says, "Where's mine?"
It's on the way, Luke. You're gonna get it.
Are they hardened drive gears?
Not on this machine, but they're gonna be in the production units.
Matt Riley wants to know whose original idea was it, and are they going to get a bonus?
I mean, this is. I mean, it's a lot of different original ideas. So yeah.
It's a team effort, right? In the business of engineers, like someone might have an idea, but an idea doesn't match the product. They're two different things.
Yeah, and then
it takes a team to
how you
develop
implement all the different stuff. And
how long has it been in development? Is this a?
So about 2 years. The idea is way older, but for 2 years we've been like actively developing it hard. Yeah.
Seeing what else is around and knowing that there's popularity within multi-material and tool changing now. So it seems like the right time for sure. How much space do you need for each tool?
I think somewhere right now we have 36 millimeters. I think we can shrink it down to like 33.
Right.
That depends on the width of the final tool head design.
Right. Yeah.
Yeah.
So basically that width there will determine how close together you can put the tools.
Yeah.
And what is it that's kind of driving that width?
I mean, it's what's going on inside. So like the width of the cooling ducts, the angle of the motor mount, and and all the secret stuff inside.
Captain Rich says, "Take my money." This is not even a question.
Sure, we will.
Krusty the Clown says, "What even is this?" So maybe if you've not heard, do you want to give a brief overview? Maybe we could have done this question first. But
I guess. So this is a tool changer where we don't actually switch the tool head, but we change the tool itself. That means the nozzle, the heat break, heat sink, and the filament path. Everything else stays on the tool head. That means you can have different materials that necessarily doesn't. It's a tool changer.
What is the length of the melt zone? I guess that sort of relates to flow rate, which we've already discussed, but...
I think it's about 30 millimeters, maybe 35.
What's that comparable to? What else is around 30?
I guess like a Mosquito Magnum, something like that, yeah.
Can you put beacon on it? I guess that's sort of two questions. What is the probing solution? What's the bed detection? Because presumably is that part of the tool head? Can it be modified with other probe solutions?
We're working towards having it part of the tool head. We're going to have to see where we end up. You can for sure mount beacon to one of the tools and just pick it up for scanning. You're not going to be able to do nozzle probing with a beacon. It would interfere too much with our integration. Maybe you can like put it on yourself, given the reference geometry. But we're not going to be doing that. Instead, we're going to be integrating it on a tool.
Yeah. So I mean, yeah. Once you've got everything we've seen so far, the tools are printing tools.
Yeah.
But as you've just pointed out, there's no reason why that tool has to print. It could do.
Yeah, I mean,
other
you can
functions.
put an oxyacetylene torch on it, I guess, if you want. But yeah, I mean, we're aiming for not only doing SED nozzle probing, but also XY. So I'm not sure if Beacon can support that, really. So yeah, that's why we don't really feel very strongly about being able to do Beacon nozzle probing.
Right, yeah.
Because what would be the point of that?
You don't need that.
Yeah.
Question is, what is the thermal path from the heater to the nozzle? I guess the question is, how is it being heated?
Yeah, it's inductive.
Yeah. So can you elaborate a bit on what inductive heating means, what it is?
I guess it's magnetic fields to like excite the ferromagnetic steel. I mean, we're heating the nozzle steel directly, wirelessly, which means, I mean, and it's only heating like a very thin section of the steel.
Yep.
Which means we only have a very thin section of the steel, so we have a very low thermal mass, and that lets us heat it up very fast, and it cools down very fast, meaning that the filament doesn't degrade while it's parked, and it doesn't ooze all that much.
Right, yep. Yeah. Which presumably is going to help with the faster tool changes, as you've already mentioned, and material waste as well, if you're not having to purge loads every time you switch.
Yeah. I mean, the primary reason we do a prime tower right now is to build up pressure in the nozzle. But we might use a different solution, because if you're doing a prime tower and you're like doing PETG and PLA, it can often fail.
Yeah, because they don't really stick to each other.
Yeah. So we're gonna look into at least recommending something different than a prime tower.
Is it really that seamless, or is it a finicky hassle? I think that's probably a question for me, because I'm not sure you're going to say it's a hassle.
No, I mean, for us, it's a hassle and it's very finicky, but that's part of the development process. For you as a user, it's not going to be too finicky.
That's going to be ironed out by the time it reaches November.
Yeah, for sure. Otherwise, it isn't a problem.
How do the nozzles align?
Right now, we're using an upwards-facing camera, and we're using like a crosshair built into mainsail to like move it around and set the offset that way.
Okay.
We're looking into different like nozzle probing solutions for XYZ offset, because we want to do it less finicky, more automatic.
What about in terms of the hardware alignment? When the tool gets picked up by the tool head, is there anything specific to kind of make sure it's as close as you can?
Yeah, we have a Maxwell kinematic coupling, and it's very, very repeatable. Yeah.
Okay. So I guess you would do maybe the nozzle offset at the beginning of the print, and once it has that data, it knows each tool what that is.
Yeah, I mean, maybe we'll do, if it's automatic, it could be done at the beginning of each print. But I mean, when we do the offset calibration one time, I mean, it works.
Oh, so you don't even need to do it per print. It's just
no.
Once you've set your tools up, you switch to each one.
It's
do
a
the
one-time
alignment.
thing. I mean, if you swap nozzles around, then you're gonna have to redo it. But as long as they're in the same tool position, then you can use the existing calibration.
How is the print quality, I guess, so far?
Yeah, I mean, it's on par for the machine, I would say. It's not really affected by the INDX system itself.
Right, yeah.
I mean, obviously, the rigidity of the tool head mounting and stuff is going to be affecting it. Right now, we have the nozzle pretty far from the rail, and that's affecting print quality. But in the iteration we're working on now, the next iteration of the tool head, it's going to be way more optimized in those terms.
Okay.
Yeah.
What kind of trees are on the...
Sorry.
It's because I took the photo of the rat rig. In the background, you can see the trees outside.
I'm not sure. Are you an arborist or something? Maybe it's birch?
I think it probably is.
Yeah.
What's the possibility of IDEX with this system?
I mean, it's probably possible. I don't really see why.
I guess the only advantage maybe is where you can print two things at exactly the same
mirror
time.
duplication
Mirror
mode.
printing.
Yeah, I mean, if you have like 2 tool magazines, then yeah, it should be very possible.
But at that
I'm
point,
not sure.
you might as well just have 2 printers, right?
Yeah, probably. but I mean, you have one heated bed, and I mean, you do you.
Yeah, I mean, in my mind, there's nothing that would really stop you having an IDEX.
No.
The only thing you'd need to make sure is that maybe both tool heads can access all the tools, or you'd have to have these 4 tools for this tool head and these 4 tools for this tool head.
We're not going to be offering those macros, so feel free.
Feel free to make them yourself. Can you only use your nozzles, or will there be a number of nozzles you can choose from?
Yeah, I mean, that's still undecided. We're not close to the possibility of partnering up. So if you're I mean, tell us what you think should be there. I mean, it's going to have to be a ferrous material, because otherwise the induction wouldn't work.
Yeah. I will say from my perspective, what you're maybe more likely to find is a tool solution rather than non-nozzle, because like that whole tool is sort of could be just provided as one assembly. That heatsink, the thread, the throat where you get the heating, and the nozzle would probably all come together, because it's quite a tight integration, right? Yeah. There's not like loads of material you can put threads and stuff in. Like, no. You'd probably want that whole thing all as just one assembly. Why are you using CPAP? I think we kind of...
Yeah, we touched on that. Yeah. It's to keep the tool head as slim as possible. So
I think their observation was having cold air blowing from outside the printer, but I think realistically, I mean, the final implementation of where you put the actual fan is sort of up to you.
That's accurate. I mean, in this case, we put the fan on the outside because it was a simple implementation for an open frame prototype. Mm-hmm. On the 2.4, we have it drawing the enclosure air, even though it's not really enclosed, but that's the design we went with for that one.
On the rat rig in particular, some people have pointed out that it looks like there's a tool head on the front and the back.
Yeah, we just wanted to cover up the other side basically. So we did a similar looking cover. So all that's going on in there is fasteners and the inductive probe we're using for this prototype.
It just so happens that the cover looks the same as the front or the back. Yeah. Do you think that would be a possibility if you had the tools aligned at the front and the back?
To have 2 tool heads?
To have 2 tool heads?
Yeah, I guess, but
you then have 2
I don't
nozzles.
really see the why.
Yeah. Is it sentient?
Yeah, it's not driven by AI yet.